Okay, so as I promised you, this second session is going to be chemistry. Yes, chemistry. And the topic we'll be treating today is electrolysis. Electrolysis. Okay, so we are going to start by saying how did this word electrolysis come from? Well, the word electrolysis is coming from two Greek words. Electro, referring to electricity, and lysis, L-Y-S-I-S, lysis, which refers to breaking down. Okay, so when we bring these two words together, one is electricity, electric, and the other one is what do you call it, breakdown. So if you bring it together, we now have something that tells us breaking down of something by the passage of electric current. Okay, so this is what we mean by electrolysis. So if I'm going to define electrolysis, I will go this way. This is the way I'm going to define electrolysis. I told you the origin of the word electrolysis. Now let's see how it applies to what it actually means. So electrolysis is the chemical decomposition. Of a compound in liquid or molten form by the passage of electric current. The chemical decomposition of a compound in liquid or molten form by the passage of electric current, or you can specifically say by the passage of direct current, because it is direct current that we use in electrolysis. Okay, so the chemical decomposition of a compound in liquid or molten form by the passage of direct current. There are many things we can take away from this definition. The first one says it is a chemical decomposition, which means it is a chemical process. It's a chemical reaction per se. Okay, so, and therefore, this electric chemical reaction is brought about by the passage of electric current. Okay, so, and the compound must be in liquid or molten form. These are things we can take away from this definition. And the first major conclusion, or what we can draw from this definition, is that electrolysis makes use of the chemical effect of what? Of electric current. The chemical effect of electric current. Because electrolysis is a chemical process, and without electric current, it cannot happen. It means that electric current has a chemical effect. And it is this chemical effect that electrolysis takes. Other effects of electric current are magnetic effect and the heating effect. So besides chemical effect, which is applied in electrolysis, electric current has other effects, which is heating effect. And when is this heating effect applied? One of those instances where we use the heating effect of electric current is when we put on our electric lamp, the usual incandescent lamp we use. When we put it on, we see that the electric current heats up the tungsten filament, and that brings about the glowing of the bulb or the incandescent bulb. So when this happens, we are applying the heating effect of current. Even in our electric iron, we see electric current heating up our electric iron, and so on. So electric current has heating effect. It also has magnetic effect, because when electric current is passed through a conductor, or one that is resistive to the passage of electric current, then what happens? Electrical energy is converted to I'm talking about the magnetic effect. So when when electric current is passed through a conductor, an electric field is generated around it. So that is why we say that electric current has a magnetic effect. So electric current has magnetic effect because a magnetic field is generated around a current carrying a conductor. Okay, it has heating effect because it heats up the tungsten filament and other materials that are resistive to the passage of electric current. And also it has chemical effect because during electrolysis, it is this electric current that brings about the chemical decomposition of a substance in liquid or molten form. There are other definitions that are very important, that are very, very germane to what we are doing. And one of them is definition of electrolyte, because these are terms we are going to meet as we go on. One of those terms is electrolyte. And what is this electrolyte? I'm going to define it. An electrolyte is a compound which is in liquid or molten form, which conducts electricity, and in the process is decomposed, which conducts electricity. So any compound in liquid of molten form that conducts electricity and in the process is chemically decomposed, we call the substance, we call the compound an